All right, we're going to take a look at Aleks 3-4, number 1. Aleks 3-4, number 1. It says, a loan of $19,000 is made at 9% interest compounded annually. After how many years will the amount due reach $62,000 or more? Use the calculator provided if necessary. Write the smallest possible whole number answer. Okay, so first, let me open up the formula chart. All right, so if you're using PowerSchool Learning, if you go to the main page, the 2021 page here, you can click here for the formula chart. You can do this, and this should open up a formula chart. Looks like I got 2 of them. Or if you're in Google Classroom, let me show you where it is. It's down here. We're going to be looking at these 2 formulas. Or if you were in Google Classroom, you would just, it's right at in the main little topic on classwork. You click formula chart right there. So either way, that's how we get to this formula chart. We're going to use one of these 2 formulas. Now, it tells us over here that it's compounded annually. That's a big key. Anytime it ever tells you in the problem a frequency of how often it's compounded, if it's not continuously or exponentially, you're going to use this formula on the left. So I'm using this formula, A equals P times 1 plus R over N to the power of NT, where N is how often per year. So in this case, it says it's happening annually, which means it's only going to happen once a year. So N is 1. Now P refers, excuse me, to the starting amount. So P is 19,000. A is your final amount, which is 62,000. So if I start to plug these in, I have 62,000 equals 19,000. 1 plus, the rate is 9%. And as a reminder, the way to get rid of a percent symbol is you divide it by 100%. If you do that, you will get your value. You can type this in the calculator, which this is going to be 0.09. So my rate is going to be 0.09 over the 1 time per year, because we're doing it annually. So honestly, I don't even have to have that 1 there. 1 times the amount of time. So I'll show you in a second how to do this by hand, but I'm assuming most students would probably prefer just to use Desmos to solve this. So I'm going to type in the equation as given. You could just do 1.09. If you want to divide it by 1, that's fine. You raise it to the power of 1 t, and 1 times t, just like that. And so there's our equation. Now, Desmos won't do anything with that t, so I'm going to change it to an x. And the answer will be a vertical line. So there's the answer. Now, it's not clickable. It's going to be between 13 and 14 years. But the way to get it clickable where you can see the exact amount is you do y equals the left side of the equation. And then you do y equals the right side of the equation. Like that. Now, they're always going to cross at the number that's by itself. That's the height. So I know it's going to have this as the x, like that 13 point something, and the y is going to be up at 62,000. So I'm just going to go to my settings here, and I'm going to put something above it. I'll just do 70,000. There we go. So now here's my graph. I see these 3 different pieces. The intersection is going to be the answer. So the answer is 13.724. Sorry, I dropped a pen here. So T, I'll write it over here. T is going to equal 13.724 years. Now let's look at what it says here. Write the smallest possible whole number answer. So we need to reach $62,000 or be more than. So at 13 years, it's not there yet. So it's going to get to 62,000, it's going to take 13 and some change, but it wants it as a whole number. So I'm going to change this to T being 14 years. That's the smallest whole number answer. That'll give me at least 62,000, which 14 years would actually get me a little bit more because it'd be higher over here. So 14 is going to be the answer. If you were going to do this by hand, the way you would simplify this is you would divide by 19,000. first. And this is going to be 62 over 19. It might reduce again, but I'm not really sure if it does or not. And then this would reduce to 1.09, because again, dividing by 1 doesn't change that number, and so I would just add those two. It's kind of like having $1.09. So I have $1.09 to the power of t. And the way to solve an exponential, if you're doing this by hand, is you convert it to a logarithm. So convert to log. Convert to a log. And so with a logarithm, you keep the base, which the base is 1.09, but the power and the number switch. So I'd have 62 over 19. All that would equal t. So if I type this in the calculator, I should get this exact same answer, unless I did a math error. So log of 1.09 is 62 over 19. And yep, I'm getting 13.7239, so on and so forth, the exact same answer.